code imports necessary libraries from the Keras framework, specifically the core and recurrent modules, which contain useful tools for building neural networks. The sequential module is also imported, as it provides a way to easily stack layers for a neural network. The time library is also imported, which is a built-in Python library used for time-related functions. The main purpose of this code is to set up the foundation for building a neural network using the Keras framework. By importing these modules and libraries, the user will have access to various predefined functions and tools that will make it easier to construct a neural network. The code does not actually create a neural network, but rather it sets the stage for building one by importing necessary resources. This code installs the PyDrive package and imports necessary modules to read a CSV file into Collaboratory. It first installs PyDrive using pip, and then imports the authentication module from the PyDrive package. It also imports the Google Colab module for authenticating with Google services. Next, it authenticates the user and creates a PyDrive client object. It sets the authentication credentials to be the current default credentials and creates a Google Drive object using these credentials. This allows for access to Google Drive contents and enables the reading of CSV files into Collaboratory. This code initializes a variable named link with the value of a string, which is a web address. The web address directs to a specific location on Google Drive. It also includes an ID that identifies the file or document that is being accessed. The code does not take any further actions besides defining the variable. It does not actually open the link or access the file. The purpose of this code is to store the web address in the variable so that it can be used later in the code for further actions. This code takes in a string value link and splits it at the equals symbol. The first part of link is assigned to fluff and the second part is assigned to id. The id is then printed to verify that the code has successfully split the string at the equals symbol and has extracted the value after it. Essentially, this code parses out a specific value from a string that contains multiple values and symbols. This block of code imports the pandas library and stores it as PD so it can be used later in the code. The next line creates a file object called downloaded and assigns it an ID. This ID is used to identify and access a specific file in Google Drive. Then, the code uses the getContentFile method to download the file with the specified ID and save it as AMZN. CSV. Finally, the read_CSV function from pandas is used to read the data from AMZN. CSV and store it as a data frame called df3. This allows for easy and convenient manipulation and analysis of the data in the file. Code begins by importing layers and models from the Keras library, specifically the dense, activation, and dropout layers from the core and the LSTM layer from the recurrent layer. This allows us to use these functions and layers in our code. Then, the code imports the sequential model which allows us to create a neural network layer by layer. After this, the code imports the time library for any necessary helper functions. Essentially, this code is setting up the necessary imports for building and running a neural network using the Keras library. This code drops any columns in the data frame that contain null, nan, values. It creates a new data frame, df3, which is a copy of the existing data frame with these null-containing columns removed. The axis equals columns argument specifies that the function should search for and drop columns rather than rows, which is the default behavior. This is useful for cleaning up data or preparing it for analysis, as null values can interfere with calculations or create inconsistencies in the dataset. The df3.head function is used to preview the first 5 rows of the data frame df3. It is often used to get a quick overview of the data and check for any potential issues or inconsistencies. This function is commonly used in data analysis and data cleaning processes. It is also useful for identifying column names and data types before performing any operations on the data frame. This code imports the NumPy library into the program using the import keyword and giving it an alias np. This allows for the use of the functions and methods within the NumPy library in the program. NumPy is a popular library used for handling scientific computing and working with arrays and matrices. This code selects the close column from the data frame named df3 and creates a series called df_close using the values in that column. It is used to extract a particular column from a larger dataset, allowing for easier analysis and manipulation of the desired data without having to alter the original data frame. Code is retrieving the shape of a data frame object called df_close. The shape function in pandas returns a tuple that specifies the number of rows and columns in the data frame. If the data frame has 5 rows and 3 columns, the shape function will return 5, 3. This code would be used to quickly check the dimensions of the data frame, without having to manually count the rows and columns. This code converts the data from a data frame stored within the variable df_close into a NumPy array. This array has a shape of 2265 rows and 1 column, essentially converting the data from horizontal form to vertical form. Code starts by importing the necessary packages matplotlib.pyplot and sklearn.preprocessing.min-max-scaler. Next, it plots a graph using the plot function from matplotlib.pyplot, specifying the data to be plotted as df_close. The show function is then used to display the plot. The next line of code creates an instance of the min-max scaler with a specified feature range of 0 to 1. Lastly, the code uses the fit_transform function of the scaler to transform the data contained in df_close based on the specified feature range. This code is used to divide a given dataset into 2 parts, a training set and a test set. First, the total length of the dataset is multiplied by 0.80, or 80%, and converted into an integer. This value is stored in the variable train_size. Then, the total length of the dataset is subtracted by the train_size to get the length of the test set. This value is stored in the variable test_size. Finally, the code uses the slicing method to split the dataset into 2 parts. The first part, from index 0 to train_size, is the training set, and the second part, from train_size to the end of the dataset, is the test set. The length of both sets is printed for confirmation. This code is useful for training and testing machine learning models, as it ensures that the model is trained on a majority of the dataset and tested on the remaining portion. This code is used to create a dataset matrix from an array of values. The function, create_dataset takes in 2 parameters, dataset and look_back, where look_back is set to a default value of 1. The first line of code is a comment describing what the function does. It mentions that the function converts an array of values into a dataset matrix. The next line declares the function and its parameters, with dataset being the array of values and look_back being the number of data points to be used as input in order to create the output value. The third line initializes 2 empty arrays, datax and data, which will be used to store the input and output data respectively. The next line initiates a for loop to iterate through the dataset. The loop will continue till the length of the dataset minus look_back minus 1. This ensures that the loop will only run till the data point before the last one, as the last data point will be used as the output value. Within the loop, the data point at index I to I plus look_back is sliced from the dataset and stored in the variable a. The next 2 lines add the sliced data point to datax and the next data point from the dataset to data. This creates the input-output pair for the dataset. Finally, the function returns the 2 arrays converted into NumPy arrays, representing the input and output data for the dataset. In summary, this code takes an array of values, slices them into input-output pairs using a specified number of data points as input, and returns the input and output arrays in the form of a dataset matrix. This code takes in a dataset and uses a look_back value of 1 to reshape it into two sections, x and y. X represents the current value and y represents the next value. The function create_dataset is used to create these two sections for both the train and test data. This is done by splitting the dataset into smaller groups of look_back elements each. The trinks and trainee correspond to the trained dataset and the test and testee correspond to the test dataset. These will be used for training and testing a model to predict the next value in the sequence. This approach is commonly used in time series analysis and is useful for predicting future values based on past patterns. This code uses the NumPy library to reshape the dimensions of the trinks and test arrays to make them into a format that is compatible with the data structure used for recurrent neural networks, RNNs. This is done by using the reshape function and specifying the new dimensions as number of samples, 1, number of features. Essentially, this step prepares the data for further processing and analysis. This code is building a sequential model, which is a type of neural network used in machine learning. First, an instance of the model is created and added to the sequential model. The LSTM layer is added to the model with an input dimension of 1 and an output dimension of 50. This will take in a series of data points and output a vector of 50 numbers. The return_sequences parameter is set to true, which means that the layer will return the full sequence of outputs instead of just the last one. Next, a dropout layer is added to the model with a dropout rate of 0.2. This layer will randomly set a fraction of input units to 0 during training in order to prevent overfitting. The model then adds another LSTM layer with 100 units and a dropout layer with the same rate of 0.2. After that, a dense layer is added to the model with an output dimension of 1. This layer will take in the output from the previous layers and output a single number. An activation function is then applied to this output. In this case, the ReLU, rectified linear unit, function is used which replaces negative values with 0. The code also requests the start time and compiles the model using the mean squared error loss function, the RMSPROP optimizer, and the mean absolute error metric. These are all important parameters for training the model and determining how well it performs. Finally, the code prints out the compilation time, which is how long it took for the model to be compiled and ready for training. The model.fit function is used to train a machine learning model according to the given training inputs and corresponding target outputs. The first argument trinks represents the training data, while trainee represents the target labels for the training data. The batch_size parameter specifies the number of samples to be used for each training batch. The NB_epoch parameter specifies the number of training iterations to be performed. The validation_split parameter is used to split a portion of the training data as a validation set, which is used to evaluate the model's performance during training. In this code, the model will be trained for 80 epochs using a batch size of 128 and a validation split of 5% on the given training data and target labels. This code is used to train a machine learning model. The model.fit function takes in 3 required arguments, trinks, trainee, and batch_size, and 2 optional arguments, NB_epoch and validation_split. 1. Trinks and trainee are the training data set or input features and their corresponding output labels, respectively. These are used to train the model and teach it how to make predictions. 2. Batch_size is the size of the batch in which the data will be processed by the model during training. It is an efficient way to train the model on a large dataset without using too much memory. 3. The NB_epoch argument specifies the number of epochs, iterations, for which the model will be trained. Each epoch involves one forward and backward pass through the entire dataset. 4. Validation_split is used to split the training data into training and validation sets. Here, 5% of the data will be used for validation, while the remaining 95% will be used for training the model. This helps in evaluating the performance of the model on unseen data and preventing overfitting. 5. The model.fit function then runs the training process for the specified number of epochs, using the specified batch size and validation split. This involves updating the model's weights and biases based on the input data and the corresponding output labels. In summary, this code fits a given machine learning model to a training dataset and adjusts its parameters to minimize the error on the given data. It is an important step in the process of building a predictive model. This code imports matplotlib.pyplot, which is a plotting library for Python. Next, it creates a variable called predicted_stateful, which uses a model to predict the stateful values for the test data, test. Then, it uses the plt.plot function to create a line plot of the actual closing prices, testy, setting the color to red and labeling it as actual closing prices. Similarly, it plots the predicted closing prices, predicted_stateful.flatten, in blue and labels it as predicted closing prices. The plt.label and plt.label functions are used to set the labels for the x-axis and y-axis respectively, and the plt.legend function adds a legend to the plot with the labels best as the location for the legend. Finally, the plt.show function displays the plot. Overall, this code is used to visualize and compare the actual and predicted closing prices for the test data using a line plot. This line of code evaluates the performance of a trained machine learning model. The function evaluate takes in the input features trinks and the ground truth labels training of the training set as parameters. Batch_size specifies how many samples are processed in each step of gradient descent. Lastly, verbose sets the verbosity mode. 0 means silent, 1 means progress bar, and 2 means 1 line per epoch. The output of this function is saved in the variable may, which stands for mean absolute error. This value indicates the average difference between the predicted values of the model and the true values. Essentially, this code evaluates how well the model fits the training data by calculating the mean absolute error.